collect incidents. They look for carcasses, they look for snares, human-elephant conflict, poaching incidents. And so this data store is building up, as well as with our tracking, our vehicles, and so on. And so what we faced was this question. So how do we best collect the relevant data and turn it then into actionable conservation information? So that's what I'll be kind of going through. Thanks. So this is our EarthRanger instance. It's probably like many. We have spatial data, we have elephants, we've got different species being tracked, we have rangers, all kinds of different events, and we've customized a lot of our event collection based off the basic event definitions. But there's a lot going on here, and this has been a fantastic real-time visualization tool for us. But we also want to couple this data with other data sources. Maybe. So another one that we use, or data platform that we use, is Google Earth Engine. So if you've not heard about Google Earth Engine before, it's this incredible tool that Google has built based off of publicly available satellite information, and they're hosting petabytes of freely available satellite information. So for instance, the entire Landsat record from the 1970s onwards is available for free through Google Earth Engine. I think they've recently commercialized it, but you can also get access to for free access. And so it's got some incredible layers. I mean, there's the Hansen Global Forest data set where they're doing yearly pixel, every pixel in here is 30 meters, where they're looking at change detection since the year 2000. And then they've got, I think this is the JRS, I forget who produced it, but a global water cover layer, so down to 30-meter resolution as well, so you can know where there's permanent water. So this kind of information is very important, obviously, in conservation. Where is there water? What's happening to the forest? What's the land cover like? Next slide, please. And then finally, a lot of us are collecting data in our areas, vector-based spatial data. So things like roads, boundaries of national parks, fences in our case, agriculture, settlements, all of these layers then come into play when you're trying to analyze data. For instance, we've just done a paper we've submitted on elephant movement and why do elephants behave the way they do. So they're avoiding settlements, they're attracted to the national parks, but you need to know where all of that is to be able to make those connections. So really we're looking at a number of different data platforms. And this is the specific one we built for our system. It is actually global. I'm not really going to get into it, but it's called Landscape Dynamics, and we've got a lot of open vector spatial data in there. So if you want to talk more about that later, I can. And then finally, we specifically with elephants as a species, we've got another platform called Elephant Book, which we've developed recently for re-identification of individual elephants and capturing demographic data specific to the species. And so we're using some machine learning, and we've got a human-based labeling system, and we have a team that goes out pretty much every day and collects sightings of elephants. So this is yet another, so this is the fourth platform then of data where we're hosting different types of conservation information. So this is where Ecoscope came into play. So we realized we wanted to be able to couple data in EarthRanger with that of Google Earth Engine. We wanted to be able to pull out layers from Landscape Dynamics. And we also want, in our case, to be able to look at elephant-specific species data. And so we've designed this Python library called Ecoscope. It's available here at this address. It was open sourced in June. And we really have tried to pack in a lot of different functionality for talking to different data platforms, combining those data, and then running analyses with them. So yeah, so Elephant Book, we're developing the API for Elephant Book, and it'll talk to that soon. We've put a lot of work into making it fast so that it runs quickly. So a lot of the functionality you'll see in it has been optimized using numerical functions. We've developed a set of tutorial notebooks. So if you go to ecoscope.io, you'll find those on the website, and you can go through. They're written in, well, they're basically Jupyter. So Jupyter is it actually stands for Julia Python R, and it has 3 different kernel backends. So you can run code from either one of those 3 languages within a Jupyter notebook. If you run a Jupyter notebook on Google, they have a really nice thing called Google Collab, which basically provides you with computational space in the Google Cloud to run these notebooks. And you'll see if you go to Ecoscope, there's an open in Collab button, and then the notebook will run in Collab. And you can actually run the examples straight from there, as long as you have a Gmail account. You can also set up Ecoscope locally and run it on your machine. It's a bit more involved to get the libraries correct. And so we are looking to build functionality to serve a community with common, sorry, my spelling mistake. Please ignore the T, I didn't see that. But to build Ecoscope for a community with common objectives and really for the conservation community. So to try and serve all of those functions within that I mentioned earlier. It's currently being supported by MEP, and generously from AI2 gave us a grant last year and this year, and so we've been, Eric, maybe put your hand up. So Eric is our new developer on Ecoscope, so if you have questions, and he's sort of taking the lead on this project for that. Yeah, okay. So some of the things that it can do. So one of the big things that we've heard is that EarthRanger is a fantastic platform, but it's difficult to get data out to run analyses. And so this is one of the first things we wanted to address. So we've developed a module within Ecoscope called ERIO, sort of for pulling data down, as well as uploading data, so it can do both. I'll run a live demo after this, but basically you can connect to Ecoscope if you have EarthRanger, if you have a login. You can download events, you can download tracking data, patrols, subjects, sources, users. So many of the tables that are in EarthRanger you can access now through this module. This is an example of pulling, so I grabbed data for a given subject group. So this is Met Elephant Mara, it says, and it took 55 seconds, and it was over 100,000 tracking data points. And then using, so Ecoscope's built on top of a couple of other libraries. One's called GeoPandas, and it natively supports a lot of different GIS formats. And so with one line, you can pull the data and then export to what's called a GeoPackage, and this just loads up either in ArcGIS, and then this is an example of QGIS. So you can pull your data down and put it into the GIS very quickly. From there, we can also do more analyses. So from the raw tracking data, we can create what's called a trajectory in Ecoscope. And a trajectory will very quickly calculate a lot of sort of data related to the track of the animal. So speeds, headings, displacements get calculated and stored in a data frame, which can then be visualized like this. So this is a speed map. So we've classified the speed column according to, I think it's an equal interval classification. And we can see quickly, where there's high speed and low speed movement by the elephant. We've also built in other things, like we have an astronomy module. So for every given recorded location, we can say, where you were on the Earth, and then what was the sunrise and what was the sunset time. And then we can classify the data according to day-night. So that comes into play quite a bit with conservation as well and protected area management. In this case, this is a data set from Mali, which is freely available on the Movescape platform. And so we use this particular elephant for a lot of the examples in Ecoscope. So here you can see this was a nighttime streak that this elephant did. And a lot of these sort of long distance movements you can see happened at night. Further to that, then we can look at space use. So we've got home range metrics built in Ecoscope. So here's a time density home range analysis. So this is where you're figuring out the speed of the movement. So this is called the elliptical time density method. And you're constraining the available area based on the speed of the animal And then you're also looking at the amount of time it's spent in different areas. And so we get quite a fine-grained view of where this elephant was spending its time. So even though this is part of its range, really these were the core hotspots, and we can draw isoplots around those. A new addition that we're adding, and this is something that's available in R, but is a recursion algorithm. So we can figure out, we're looking at the time, but if an elephant returns to a given point on the landscape frequently. Of course, I'm using elephants here, but it could be many other species, including rangers. So how often have your rangers returned to a given point on the landscape? And so we've run a recursion analysis, and then we've done clustering to pull out the highest levels of recursion. And this is what it's coming up with. So these are, water points that the elephant spent a lot of time at, and then good foraging where it's returned to time and again. We've extended the work that was started by George and Guillaume with the Movescape analysis. So this is basically taking your set of data points from an animal and from a population as well, and then looking at it from a network standpoint. So if you look at the nodes and edges as being the recorded locations and the tracks between them. And so this is one way that we can summarize the data to quickly pull out connectivity in the landscape. So what we're looking at is, so what we've called it is ecograph, but it's one layer of an ecograph, and this is called a betweenness index. So this is telling you how connected is every point in the landscape to every other point. And so if you were to remove a given pixel from the landscape, you would be able to quantify how connected that pixel was to every other point. So this is a nice way of summarizing data in terms of connectivity. In our system, one of the things we're looking at is connectivity between the Mara Reserve and the Loita Forest, pictured here. And this seems to be a movement that elephants do quite irregularly, but we think it's quite an important connection to maintain. So this is an ongoing analysis that we're running to look at connected movement within the ecosystem, and particularly in this area. It's called the San River Corridor. Then, as I said, in our system, we've got a lot of conflict, so growing conflict issues. We get elephants doing this kind of thing, going out in big agricultural areas, especially at night, and also into subsistence community areas. The result is often not pretty on both sides. There's a lot of crop damage. There's human injuries, and then we're also seeing elephants are getting injured a lot as a result, especially with arrow wounds. So we're trying to develop more sophisticated movement analyzers to look at the data in real time. So if you see in EarthRanger, there's 4 analyzers baked in. There's the immobility, there's a low speed analyzer, there's a geofence analyzer, and a proximity analyzer. And actually all 4 of those use Ecoscope, or an earlier, slightly earlier version of it, to do that analysis. And so what we're trying to do is extend some of that functionality to include more sort of in-depth analysis. So we're looking at here is bifurcating the data into both crop rating and non-crop rating behavior based on training a model to identify that. And so what we find is that elephants, especially habitual crop raters, can enter this sort of mode of frequent crop rating behavior where it's almost every night. And so they're working out of these staging areas, out of these forest patches, going out into the crops and hiding. They'll kind of do this for weeks on end. And then they switch back into a more regular sort of meandering foraging behavior. So this is one particular elephant called Ivy, and she's our longest tracked elephant, nearly 10 years of data now. But we've had a student, Nathan Hahn, who's recently put this together as part of his PhD, and it's really interesting how it's so clear how there's these 2 kinds of behavior. So we're hoping to expose these kinds of analyses within Ecoscope. So it makes it, it's not just a PhD thesis that's going to sit on a sup info of an academic journal and no one uses it again. we'd really like to operationalize these algorithms as things are built, especially anything coming out of MEP. And hopefully, if we can grow a community that's interested in contributing and putting these kinds of things back into the system. Finally, we've also worked on tools to make it easier for reporting. So we've built what's called Ecomap, which is built on top of something called Leaflet. And so this is an open source mapping client that we've extended and added additional functionality to. But you can see here, we can very quickly drop the track of something that was tracked in EarthRanger. We have sighting events that were also tracked in EarthRanger. We've loaded polygons that we got out of our landscape dynamics database. We've added information from Google Earth Engine, and now we've got a map client, and we can programmatically add or drop things like the title or the legend or add a north arrow, and then we can export that both to a static file. So if you want to do a monthly report as a PDF, this also can be rendered as an HTML client that you could embed in a dashboard. And I'll show you that in a little bit. Other things we're working on in Ecoscope, and not to infringe, but to hopefully bolster some of the work, for instance, Global Forest Watch is doing, but we've got a deforestation module that we're developing that can use that Hansen data set in Google Earth Engine. So we can basically draw a polygon and then pull down all of the Hansen data set and classify it according to forest loss and current forest. And so this is an area in the Mara called the Nucleary Forest, which has been heavily deforested in the last 10 years. Associated with that is a tool to do trend analysis and a survival curve. So this is a Bayesian model that's been fit to the survival curve to model deforestation over time. And you can really see, 2012, and then there's suddenly this sharp decline. And so this is ongoing work we're doing. And there's some images of that forest. But more generally, we'd like, this tool is now available within Ecoscope to be able to do this analysis for any AOI. Another thing that we've baked into Ecoscope is the ability to calculate anomalies. And so an anomaly is basically where you take a mean value of a quantity that you're interested in, like sea surface temperature or rainfall or NDVI. In this case, we're looking at albedo, which is surface reflectance. And we have the tool, so it will extract data, Google Earth Engine imagery data from the AOI over a 10-year period, calculate a mean value, and then it looks for the period that you're interested in, it calculates what's the cumulative sum above or below the mean for every year since. And so we've done this in the Mara for 4 different sites. So we have the Mara Reserve and Siano, which are quite protected areas. The community conservancies, which are a mixed use livestock and wildlife area. And then outside in the Loida Plains, where there's no protection and it's farming and it's livestock. And you can see very clearly the difference. So basically you have seasonal fluctuation in the protected areas, but we're back to the level of surface reflectance that it was in 2010. Whereas outside, you can see that there's seasonal fluctuation, but it's climbing. So the trend is going up. So again, you can use this pretty much anywhere and just run that as a tool within Ecoscope. We use this in our monthly report. So this is NDVI trend analysis. So we have, again, you define an AOI or area of interest, and then it'll extract all of the NDVI information that you specify the time for. And in this case, this is a month-long period, and the blue represents the current values and the trend, and the green is the historical variance. So over that month, how much did NDVI used to vary? And so in the month of May, across the greater Mara ecosystem, we were pretty much on the median of the historic values. And so, but if we were to run that now, and I wish I had that graph ready, but we would probably be much, much below the historic, the 5th percentile, I would estimate, given the drought-like conditions in Kenya. So this is a very nice visualization of what the system is doing and how green vegetation is within the system. and how dry it's getting effectively. So taking that same logic, we can apply that, for instance, to another value, which is collar voltage. So we, as part of most collars, they record the battery with every position. And so this is a Savannah tracking collar. So we've pulled the tracking data set out of EarthRanger, and then we're running that same sort of logic. So we're looking at, what was the historic average, what was the variance, and what is our current collar voltage over the last month. And this is a really easy way to figure out if your collar is starting to fail because of the battery. So again, that's a sort of baked in algorithm in Ecoscope that you can run. So in terms of reports, so going back to the exploratory data analysis, we've come up with sort of, we've got the individual Ecoscope functions, and now we've strung them together into this analysis workflow to produce what we're calling a subject report. So this is per tracked subject. So we store information in our EarthRanger on subject information. So we have, the sex, the name, the date of birth. We have some ID notes. We have a distribution and a biography that we've written for every one of our tracked elephants. And that information is very easy to store in EarthRanger. And so our code can then talk to EarthRanger, can pull out the subject information. It can then get all of the tracked data for that subject. And we do an overview map. And then using that overview, we calculate what was the seasonality. So we have a tool as well for calculating seasons. So it basically takes the AOI, extracts NDVI information, and then fits a histogram and figures out, were you on one side or the other of the median? So was it wet or dry? And so then it reverses that, figures out when was the system wet or dry, and adds that to the graph. So we have a kind of a nice way of seeing, was that a wet season movement or a dry season movement? So part of the analysis then does a speed map, calculates the total time tracked. So this is 3.1 years, how far the animal traveled, and what was its max displacement. We then use the seasonal information to calculate two different home ranges, so a wet season, dry season home range, as well as the minimum convex polygon. And then we can see what the seasonal overlap was like, and how much did that vary. So we get some range metrics. And then we can also talk to our landscape dynamics database and pull out protected area regions, and then figure out how much time did the elephants spend inside protected areas, outside protected areas, in Kenya versus Tanzania. And so it's able to summarize, so we call this a reduce regions calculation, and basically aggregates and summarizes a value like home range over polygons. So it stitches all of this together, and we have you basically design an HTML template, which the results get stuffed into, and then it can iterate this over as many subjects as you want. So this we've calculated for about 70 elephants, and it takes 2 hours to run, and we get a PDF with this information summarized for each individual. Then we've developed the population level report. So this is more of an aggregate for a given, say, subject group in EarthRanger. Many of the same types of things, but done over the whole population. So here's the raw data. Here's a 50th percentile sort of core hotspot plus 95th percentile dispersal area. Here's the wet season, dry season. Here's the speeds. Here we've got another management tool in Ecoscope that can generate a Gantt chart for your collars. So if you want to see over what time period you had data reporting and at what frequency. And then here's that seasonal NDVI distribution that we can then generate our seasons from. So this is definitely a work in progress. There's some other things that we're probably going to add to this quite soon. One would be a day-night ratio map. So particularly with elephants, they change behavior depending on the diurnal cycle. And so elephants that feel, and actually this is Fustus who's standing in the back, some of his work, tortuosity and movement behavior will shift at night when they feel threatened. So they'll do more at night when they're in an area they feel threatened. So we'll be adding that and possibly some other outputs like that connectivity, the overall ecosystem connectivity output. So this will end up being a 6-panel map. Yeah, I'd love feedback. As I said, it's an open source project. We want to make sure that we're able to take that data, turn it into information. And so we need to know what are the types of information that sites are interested in reporting on. And I think there's a lot that we can do as a community to kind of rally around defining what those things are. And of course, scientific analysis that gets down into the weeds and is developing a very specific model maybe isn't appropriate for putting in an Ecoscope, but if we can operationalize the outputs of some of these more advanced analyses, then we can all share them as well. Yeah, so one of the things we're working on right now, barrier behavioral analysis. So this is a new publication 2021 with looking at movement and behavior in relation to things like fences and linear structures, and so how, and quantifying how an animal changes behavior. We're working on a product called Ecoscope Server, which will basically take that sort of population or subject level report and then automate it. And so it'll be hopefully very easy to replicate that across different EarthRanger sites. So there will be no coding. It'll just be, this is my subject group. Here's some of the parameters. Here's my authentication information. And then here's the schedule I want it run on. So do you want it every month? Do you want it every 5 minutes? And I think there's so many different things that we can put into that and automate, especially sort of analyzers that you would want to run in a real-time setting. So we're working on some of the infrastructure challenges around that and working through those. But hopefully we'll have something running soon. We'd also very much like to build a GUI, so graphical user interface around Ecoscope so that you could open QGIS, for instance, and then run all of those functions, but without having to write any code. It would still be calling Ecoscope, but it would, as a non-technical user, it'd make it more accessible. We're trying to build tutorials and documentation and maybe do some training, and then thinking about these standardized reports and dashboards. So the collared population report, we'd very much like to do a conservation effort report. So where have the rangers gone? How much time have they spent per quadrant? What's the number of events they're collecting? Some of that has overlap with some of the things SMART is doing. But I think it'd be really good to figure out what is working in SMART, what isn't, and maybe have a lot of discussion around that. Was it the rainy season when they didn't travel very far, for instance, is something that we could do in Ecoscope. Aerial census report, so we're like to work more closely with our partners WRTI and KWS in trying to help bring in all of the national census information into the WRTI EarthRanger site and build appropriate analyses that would then tell us and give us sort of demographics straight out of EarthRanger within a notebook or in Ecoscope Server. Yeah, and we're working on an elephant demography report that would be more specific to elephants, but could potentially be generalized to other species as well. Yeah, so this is the PowerPoint part of my talk. I guess I'm going over. I might run through one Ecoscope notebook just to show you, and they say never do a live demo, but we'll try. But I'd very much like to thank WRTI, KWS being our major partners in Kenya, and the support that they've given us, and being able to do the kinds of things we're doing with collecting data, and it's really been fantastic. So thank you. And then to everyone that's been involved in developing and putting Ecoscope together so far. And hopefully we build more people that have Python coding or DevOps skills or database. Cool. So I'll show you a live demo now of using Ecoscope to pull data from our EarthRanger, so it doesn't look like I'm just making up slides. Okay. Okay, so this is the website. So if you go here and then you click on, where is it gone? If you click on notebooks, and then you'll see we have a number of example notebooks. And I would say these are exposing maybe 50% of the functionality we've coded. And we need to get up to speed with providing more examples and better documentation. So more soon. But here is, for instance, our IO notebook. So basically a Jupyter notebook, if you're not used to coding, can be a little intimidating, but it's actually very easy. All you have to do is click play buttons. And so this play button appears, and I just have to run that. And then that cell of code will run. And I don't actually have to change anything. So I know if you're not a coder and this might seem foreign, it is quite easy with a little bit of time investment. And as I said, we're hoping to build wrappers around so you don't actually have to see any Python. So I've pre-run this one. So I've installed a library, I've imported things. We have our fancy logo. I've connected now the notebook to Google Drive. And so any of the outputs that I create are gonna automatically get stored in my Google Drive folder. So they're not publicly accessible and I can access them from there. And then here's my authentication EarthRanger. So I'm just telling it, I want met.pandas.org, my username, and then I get a dialog here where I've typed in my password, and then I'm authenticated. So here's an example, for instance, of pulling. So this is a little bit tricky, but you have to know the event type from your EarthRanger instance. So in our case, this long, ugly string represents an elephant sighting event type. So you have to kind of know that. We do have a function, I just didn't have an example of it, where you can pass in the event type name. It's just if you happen to have a site where you have the same event type name for two different types of events, the system wouldn't know the difference. But so here I can pull all of the data for October. So I click go. So it's talking to EarthRanger now. I'm pulling those elephant sighting events down. Okay, and so I get a data frame with all of the event type information. So including files that were, so in our case, we take photos of the elephants when we take the sighting. So I've got links to the files, and it provides a very rich, like all of the underlying data that's stored in EarthRanger comes down. So this is 89 sightings. We have tools for, you get this ugly thing called JSON. So I think it's JavaScript object notation, but it's basically these squiggly brackets, and then you have commas and you have things embedded in that, but we can break that out into columns. So it's easier to render. And then we can, and then I can export that table if I want to a GIS and then open it in QGIS. Here I'm getting, I can get subjects, the subjects table. So here's Ivy, that crop raider, and we have another elephant called Audrey. So we're just looking at the first two rows of the 21 elephants in that data set. Here is the get observations. So we have a way to pull out observations and also do filtering. So EarthRanger actually has pretty sophisticated filtering under the hood. And it's maybe not something that you would really know, but when data gets ingested in EarthRanger, you can set up filter flags, which get tagged to every observation. And then you can filter those out if you want, or look at the entire data set. So if you consistently have data that, the GPS is jumping and you've got that one point that every time you create that map, that GPS location's way out in the ocean, you can go in and you can filter that by setting a manual filter flag. And then using Ecoscope, you can just decide not to pull that data out of the database. So here is, so this is the MAP Elephants Mara data set. So we're now asking EarthRanger for, and we've put in this progress bar so you also can see how fast things are moving. So it's talking to EarthRanger now and pulling out data, tracking data. In this case, I've told it to include subject information. So in the columns that come out, I'll have the name, the sex, the color, the preferred color, and sort of additional information. I can also do the same for the color. So if I wanted to know what kind of color it was, AWT, electronics, etc. And then I can include information about each observation. So like battery, like whatever else the collar stores when you pull it. What's nice about running things in Collab is this is a Google internet connection to EarthRanger, which is also stored in Google. So it's as fast as it can be. And this isn't using my local internet to actually pull the data down until I click save, and then it pulls the data down. So a lot of the analyses you can run in Google Colab. I have a pro account, which you can sign up for, which gives you quite a lot of resource. So you can see that, well, sorry, this is the basic level, but if you have a pro, if you're logged in as the pro level, 51 gigabytes of RAM. So it's a much bigger laptop than I could afford. And out of the box, you get 12.5 gigabytes of RAM and a certain amount of disk storage space. And you can run multiple Collab notebooks at once. So I could be running, pull the data here and do something with it here. So we've run now that we've pulled 110,017 observations from that subject group in just over a minute. And as the EarthRanger engineers tell us, when the move to BigQuery happens, that'll be very fast. So, so I think performance-wise, this is getting really, really good compared to a lot of other systems we've used for tracking data. One thing that's come up is that we were really excited about was the patrol functionality in EarthRanger. And so you can define patrols, which are effectively a time filter for your tracking data. So you're basically saying there's a patrol start and a patrol end. And in this case, we've started doing distance counts in the Mara. And so our team will start a distance count patrol, and it's linked to their tracking device. And then they end that patrol. And so in Ecoscope, we've exposed a function called get observations for patrols. And you feed it the patrol type, so distance count patrol, and it'll just pull down the observations that occurred during those patrols. So that helps filter out, when the car went to go get cooking gas and whatever. So we're just pulling down tracking data for when we were looking for elephants. So I think I've gone over, so I'll stop there, but happy to do more demos or talk more. And I think it would be really nice to talk more about, we shouldn't just be collecting data for the sake of collecting data. We should be collecting it for purposeful outputs. Is it corridors that we want to identify? Is it, where there are poaching hotspots? Is it, where there's severe land degradation? And then let's, work backwards, figure out what tools and what systems we need, and then let's start collecting in the right way to begin with. But I know there's been a lot of thought on this, both in SMART and other systems, and this isn't necessarily revelatorily new, but it's a new technological tool that we can use. So anyway, I'll stop there. Thanks very much, and please, questions. Yes.
This is all super cool and it's really exciting, and a lot of it revolves around colors and having color data, but you also have elephant book, and so with that you have individual IDs and locations of elephants.
Yeah.
I'm wondering, is a future plan to have all the elephant book stuff
Yes.
into mapping
Yeah.
the same way?
I haven't shown it, but we already have a report that it's a bit Juakali still, but it's to pull the elephant sighting data. And with each sighting, we record new and active injuries. And so we have a way, for instance, of summarizing a map showing you, where the elephants were sighted, where our team went to see them, and then some of that attribute information as well. So yeah, but to do that, we have to talk to EarthRanger, we have to talk to Elephant Book. And so Ecoscope is kind of this middleware that can pull those data sets, combine them, and then hopefully create meaningful outputs. So I think, for your lions, it'd be excellent to talk about, what kind of report would you like to see from that? So.
Absolutely, thanks.
Yeah. Yes.
You mentioned briefly that it can be used to put data into EarthRanger.
Yeah.
Can you talk a little about that?
Yeah, so it's permission driven. So with that IO module, obviously EarthRanger requires a structure, and so there would have to be, if you handed us an Excel sheet with collar data, you would have to write a data wrangler basically to turn it into a relocations object. But once it's into a relocations object in Ecoscope, we can push straight to EarthRanger. And same for events. If we have an events data frame, we can push to EarthRanger. So it's two-way. The API on EarthRanger is two-way. But it can be dangerous if you have full permission and you do something silly. Which I've done. Yeah.
What kind of proficiency in Python and coding script do you need to be able to get these visual outputs like the maps and that sort of thing? If you needed to take them to a presentation or a meeting at some sort of management meeting.
I think you have to at least want to learn and not have an aversion to code. But in theory, it's pretty easy. Like if you look at, for instance, we have a time density map example. And really, if I wanted to create a map here, so I've created this is sort of a stock map, but if I wanted a different base layer, for instance, I just have to look up the reference for EcoMap, and there's literally one line of code that you'd say base layer equals like Esri topographic or whatever. And so you could change the map around pretty easily with just a few tweaks to what's there. And so the hope is that those notebooks really provide a reference and show you how to do all kinds of stuff in different ways, and then you can copy and paste in your own workflow, or just use them straight out of the box to calculate like elephant home range, like that, or whatever metric it is.
Okay.
Yes?
I'm just interested in your provided you chose Python over R for this. R is much more widely used in the ecological community.
Yeah, I know. I think I did a lot of coding in R during my PhD in like 2008 when I started. That was definitely the platform. Since then, I think I was embedded with the EarthRanger team from 2015, and I think just really got interested in Python, and we had to do the analyzers in Python. Way back, I used to code in C#, and I did a lot of stuff on the Esri platform, and we have a movement ecology extension for Esri written in C#. Python to me is just more natural, and I think it hasn't caught on in ecology, but it's very much the lingua franca of machine learning and computer science. And so I think where we're at is kind of the middle now, where you have computer scientists working on ecological problems and vice versa. There's good libraries in R like 80 Habitat and things like that for calculating, say, home ranges, but there was literally nothing in Python. So we also thought, well, let's do some of these in Python. And one of the developers I worked with said he'd rather have a gun put to his head than code in R. So that helped to move us towards Python.
I think Python is in the ecological science, but more on the remote sensing side.
Yeah.
I think the reason why everybody with R is because of packages are so developed,
Yeah,
you can do an awful lot of things that are not available. And most people don't want to have to do base coding on any of these platforms,
Yeah.
be it R, Python, whatever, in these languages to implement their analyses.
Yeah. Yeah, I hope we get to a point where you're not really, if you're not a coder, you're not having to see, I apologize, but that we would have a GUI, you could do drop-down menus, and then we have a server instance that runs these things that you put together, or a coder has put together. I think the Move Apps solution that Andrea talked about, you know, is really neat, where it's sort of graphical user interface, but you can create your own workflows. So I think we should have some discussions on that, and you said you were supporting Python potentially. So I think, you know, one of the big things with Python too is that Google Earth Engine provided a Python library, and so we were able to just call a lot of the functions in Google Earth Engine by choosing Python. I think there's now an R library for Google Earth Engine, but we, you know, this started long ago. So.
So one thing that would be really valuable is that there's been a limited, I guess, brain trust of people thinking about outputs that would be highly valuable in different contexts. And so I think one thing that's really needed is much wider thought and input from people dealing with different problems.
Yeah.
Even if they aren't immediately implemented, just getting an idea of what are people using, what they find highly relevant and powerful for a given context would be really beneficial.
Yeah.
Because we're all, groupthink is great.
Yeah.
You're so proud of yourself all the time, but you miss a lot.
Yeah. So, so we open sourced in June, and so if you want to get your hands dirty, there's you can jump in. Otherwise, please reach out to myself or to Eric, and we'd love to carry on the discussion. Cool. Okay, thank you.